Hi, my name is David, the CAD and Design Lead for First Tech Challenge Team number 7149, the Enforcers. We are an experienced and gracious team, and we have developed an incredibly unique and effective robot for the Power Play game this year.
Many of our design innovations this year have origins at the game reveal. During reveal, we predicted that cones would be prone to falling over, even at the highest levels of play. Because of this, the most defining trait we wanted our robot to have was the ability to pick up fallen cones during a match. To accomplish this, we designed an active sweeping intake, the only one of its kind in New Jersey and one of the only ones in the world. Spinning noodles sweep cones up our ramp and into the cone-orienting cradle. Both of these pieces have had their geometry optimized for smooth transfer, and our cradle has been specially designed to reorient cones for easy pickup. In addition to our intake, we can pick up cones with an arm mounted above the intake, which we call the auto arm. The fingers at the end of the arm were taken from the very first robot we made this season, which we built during the first week. They hook into the inside lip of the cone, and the virtual 4-bar lets it stay level with the ground when picking up. By driving the chain on the virtual 4-bar, the fingers rotate back, allowing the auto arm to seamlessly hand off cones to our claw during autonomous. Despite claws being the most common scoring mechanism this season, we have designed ours with a multitude of innovative features. Our claw has 3 degrees of freedom, allowing for a huge range of motion. The claw's geometry has been optimized to perfectly fit around a cone, which in combination with a flexible foam underlay and a high grip Dicem surface, gives us a strong grip on cones while still allowing for some misalignment. The opening of our claw is driven by linkage, which has a distinct advantage of locking the claw in the closed position. This is mounted on a 180-degree rotating wrist, which allows us to pick up cones from our cradle regardless of their orientation. These components are attached to a virtual 4-bar arm. This arm is geared 2 to 1, which means that while the arm itself rotates 180 degrees, the claw rotates 270 degrees, allowing us to score cones from their knocked over position in the cradle. The gears themselves are custom 3D printed herringbone gears, meaning we don't need to worry about teeth skipping or the gears misaligning thanks to the unique tooth shape of the gears. This claw assembly, in addition to our intake and auto arm, gives us 3 ways to pick up cones around the field, giving our robot extreme versatility. Of course, our claw would be useless without the lift it's mounted on. We've designed a custom double reverse 4-bar lift, allowing us to easily reach every pull height. We chose this mechanism over linear slides to avoid the hassle of rigging and for the ability to add springs, counteracting the force of gravity when lifting and reducing required torque. On the software side, our robot is equipped with an array of sensors to help control the robot during both autonomous and teleop. We use 2 Logitech webcams, one of which is mounted below our claw while the other is mounted on top of our intake. We use OpenCV to scan our custom signal sleeve during auto so we can park, while the other webcam is used to scan the cone stack, allowing our robot to precisely aim the auto arm to pick up cones. We use 3 dead wheel odometers which accurately track the position of the robot during auto. Our double reverse 4-bar lift has 2 potentiometers measuring the angle of the bottom bars, which lets us determine the lift's precise height as well as calculate the torque put on the motors. Our intake uses a magnet and corresponding magnet sensor to ensure our noodles always stop vertically, keeping them out of the way when not intaking. These sensors and others are utilized to their full potential to make our robot efficient, reliable, and intuitive to drive. Every part of our robot has been meticulously designed for effectiveness and to maximize scoring potential. We've gone through countless failed prototypes to get to where we are now, and even relatively minor pieces like our bumpers have been through dozens of iterations. Our hard work and impressive engineering skills allowed us to score the current New Jersey state record and helped us win the Inspire Award at our league tournament this year. While we have a unique and effective robot, it could not have been created without the collaboration of 7149's members. Although we have separate teams dedicated to building, design, programming, and business, they all work in tandem to ensure progress is always being made. Our designers work with the builders to ensure mechanisms are easy to assemble and to integrate wire management channels into our pieces. The builders and designers work with the programmers to integrate necessary sensors into our robot. The programmers work with the drivers to make controls intuitive, and everyone collaborates with the business team for engineering documentation and help get our portfolio done. No aspect of our robot was made by just one person, and good teamwork and communication is instrumental for our success. Team 7149 believes in the first core values of gracious professionalism and cooperation. We strive to help other FTC teams whenever we can. We directly mentor an FTC team my high school started this year, helping them be on a winning alliance during their second meet. We teach at workshops, introducing new first participants to beginner programming, design, and build concepts. We started a Discord forum this year, giving teams around the world a place to get help from us and each other. And at competitions, we always help teams who need it and frequently volunteer to help keep events running smoothly.
Team 7149 is proud to have such an innovative robot and sportsman-like team, and we hope to keep succeeding at the New Jersey State Championship. Thank you for watching, and may the Enforcers be with you.